Okay, today what we're going to look at is inequalities that actually lie between two x values. We haven't looked at that before, so we're going to see what it means for an x value to actually lie between two different values. Now just to recap, if we had an inequality such as this, where x is less than 4, we've got 4 in the middle, and we fill in the rest of these. If x has to be any value as long as it's less than 4, well, it's an open circle because it's a less than, not an equal to, and it's any value that's less than that. Okay? Now, what would happen if we had an x value, once we've solved our inequality, which had to be less than 4, just like before, but this x value actually had to be greater than 2. What values could it actually be? Well, it has to be, at the same time, this is saying x has to be greater than 2, but it also has to be less than 4. So when we actually plot this on a number line, graph this, 2, 3, 4, let's just fill in some values here. It's not equal to 2, so we need an open circle there. It's not equal to 4, so we need an open circle there. And we know that x can be any value in between that. And so what we do is we fill in that line there. And that's actually graphing an inequality between two different x values. So let's have a look at another one. Okay, here's a different one. We've got -5 less than or equal to x, less than -2. So if we draw up our number line, now this time we need to make sure we have -5 and -2 on here. So let's just start there at -6, -5, 4. Okay, so we have a bit of a range there. Now what do you notice this time? X has to be greater than or equal to -5. So when I put my, I'll do it in a different colour. When I put my circle here, because it can actually be equal to it, that needs to be coloured in. What else do I know? It has to be less than -2. It's not equal to this time, so it's an open circle there. And x can be any value in between those two. So I fill in my line there. And that's showing me that x has to be greater than or equal to -5, but also at the same time less than -2. Okay, now I want to show you a slightly different one here. I've just got a number line here, and let's just choose some values. Let's say that x has to be something to do with 1 there, and our other x value, let's go with 4. Now you might colour 4 in, so that we can also have it equal to 4. Now this time, instead of my solutions for my x value to be in between these two limits, so that it would be greater than 1 or less than or equal to 4, this time I'm actually going to colour in the arrows pointing outwards. Now how would I write this as an inequality? Because this is a possibility. This one here is saying that, well, x has to be greater than or equal to 4, but at the same time, what is this one actually saying? Well, this one's saying that my x value has to be less than 1. And both can actually be true at the same time, and so our inequality would actually read this: x less than 1 and x greater than or equal to 4. Both of those solutions would satisfy the inequality that we would get in a particular question. So let's give another one like that. Okay, here's the next question. We've got x has to be less than 2, and at the same time x could be greater than 5. So let's fill in our numbers here. Okay, make sure that you have a little bit of a range. You don't need to go crazy, as long as all of them are sort of represented there. X has to be less than 2, so it's an open circle there at 2, it's not equal to, and I want all the x values less than 2, so my arrow is pointing that way. And at the same time, x has to be greater than 5, again, an open circle, and I want all the values greater than 5 there. And that's actually the way that I graph that. I have two different ranges of solutions. That one's for that one, and that one's for that one, and they are both true at the same time. Well, now we know how to graph them. Now it's a question of how do we actually solve these sort of inequalities, where our answer, our solutions, can actually lie between two different values. Here's an example of one. We start with knowing that 4 has to be less than or equal to x plus 1, which is also less than or equal to 7. So, the way that we actually do this is we sort of just pretend if we just had this as our question, how would we go around solving that? Well, we'd want to get rid of that plus 1, wouldn't we? Well, we're going to do exactly the same thing. Instead of just doing it to one side though, when I subtract 1 and subtract 1 from that side, well, I actually need to subtract it from here too, because I really have 3 kind of sides to this. I've got my middle section here where I want to just get x, but I have this right-hand side here and I have this left-hand side. So I really want to do this step, whatever this operation is, I want to do it to all of those values. And so what do I get? Well, I get my x value in the middle, that's what I wanted to get, because my plus 1 minus 1 cancels out. Remember, I keep that same sign there, because I'm just subtracting 1. 7 minus 1 gives me 6 there. On this side, I still have the same inequality sign. 4 minus 1 gives me 3. And this is actually my solution. So, let's suggest a value that might actually satisfy this inequality. If x has to be at the same time less than or equal to 6, but has to be greater than or equal to 3, well, because I've got an equal sign here, I could have 3. What else could I have? 4, 5, or I could have 6. Now, they're just all my whole numbers. I haven't even mentioned the fact that I could have 3.5 or 4.5 or 5.5, or I could have 3.1 or 4.1, so on. As long as it's any number between 3 and between 6, it will satisfy this inequality. So let's have a look at another one. Okay, how would I do this one? Remember, ask yourself the same question. If I want to get x by itself, what do I have to do to it? Well, I want to get rid of that coefficient, so I want to divide by 2 so it cancels. And so I divide by 2 to every side of this inequality. And then I rewrite 12 divided by 2, 6, has to be less than or equal to my x, which has to be less than or equal to 8. And there's my solution. If I wanted to graph this, draw up a number line, put in some values, make sure it's even. And what would I have? I have it's equal to there, and it's equal to that there, and I want any x value in between. Nice and easy. Let's do another one. Okay, here's 2 different ones here. Same sort of idea though. To get x by itself, on the left one, I want to multiply everything by 3 to get x by itself, and so I end up with that 3 is less than just my x now, because those 3's cancel, which is less than or equal to 12. And same on this side. This time though I want to multiply everything by 2. And so I get that 14 is less than or equal to just the x there, which is less than now 20. Just be really careful with the signs. You want to make sure that you keep the same sign as what's up there. So this was a less than, however this one here was, that one was a less than or equal to. And this one was opposite. This one was a less than or equal to, and this one was a less than. Okay, and they're my solutions. So, beautiful. One more. Okay, this is just an example of a couple of steps in solving an inequality between two x values. So the first step I want to do to get rid of this, I don't know if you might be able to guess this, but I want to minus 1 from every side. So what do I get? 4 is less than or equal to, now I've just got my 2x, which is less than 8. And then do my next step, which is divide all sides by 2. And so what am I left with? 2 is less than or equal to, that cancels, I've got my x, which is less than 4. And there we go. There's my solution. Now I lied, I'm going to do one more. Okay, this is just one of your 3-step ones. What am I going to do first here? Well, I need to get rid of that denominator, don't I? So I need to multiply that whole numerator there by 3. And if I do that, then I want to do every side there, multiply the numerators by 3. So let's rewrite this, and I get 9 is less than, those 3's cancel, 2x minus 3 is less than or equal to 15. Now I want to get rid of this constant, so I'm going to add 3 to cancel it. So I end up with 12 is less than 2x, which is less than or equal to 18. And my last step would be to divide everything by 2. And so what do I end up with? I'm running out of room here. Okay, so then I end up with 6 is less than or equal to my x. Whoops, just less than x. And this is less than or equal to 9. There we go, there's my solution. And I think now you are quite capable of solving these on your own and actually drawing these as graphs. So there you go, that's about the hardest inequalities that we do in Year 8. And I think you guys are doing really well. Well done.